Hello friends, welcome back to the CSC guy. This is our second lecture of we discussing introduction to importance in introduction to data science. So in this lecture, first question is we are going to compare and contrast descriptive, predictive and prescriptive analytics. Descriptive, predictive and prescriptive analytics are three types of business analytics that serve different purposes and provide distinct insights. Descriptive analytics focuses on historical data, analyzing what happened in the past. It provides insights into trends, patterns and correlations within the data. This type of analytics is used to summarize and describe the past, often using data aggregation and data mining techniques. Next, predictive analytics, on the other hand, uses statistical models and machine learning algorithms to forecast what could happen in the future. It helps anticipate potential outcomes and trends, enabling proactive decision making. Prescriptive analytics goes a step further, recommending actions to achieve desired outcomes. It combines data, algorithms, and business rules to suggest the best course of action. So let us. This is a summary of key differences between descriptive, predictive, and prescriptive analytics. First is focus. Descriptive analysis focuses on what happened in the past. Predictive analysis focuses on what could happen in the future, and prescriptive analysis focuses on what should we do. Next, techniques. Descriptive analysis uses data aggregation and data mining techniques. Predictive analytics uses statistical models and machine learning tools. Next, prescriptive analysis. It uses optimization and simulation techniques. Next are goals. Descriptive analytics goals are to summarize and describe the past. Predictive analytics goals are to forecast the future, and prescriptive analytics goals are to recommend actions. Now let us see some examples of each type of analytics. Descriptive analytics and examples are annual revenue reports, social media analytics, and inventory management. Next, predictive analytics. Some examples are credit risk assessment, customer churn prediction, and demand forecasting. Prescriptive analytics examples are identifying the best marketing channels, optimizing supply chain operations, and recommending personalized product offers. In conclusion, each type of analytics serves a unique purpose and provides distinct insights. By combining descriptive, predictive, and prescriptive analytics, businesses can gain a comprehensive understanding of their operations and make data-driven decisions to drive success. Next question to discuss is various types of data encountered in descriptive analysis. In descriptive analytics, data is categorized into different types based on its characteristics, properties, and the level of measurement. Understanding these types of data is essential to choose the appropriate descriptive analytics techniques and to interpret the results correctly. Now let us see some main types of data encountered in descriptive analysis. First is quantitative data. In this, it is a numerical data that can be measured and compared. Examples include continuous data and discrete data. Next is qualitative data. It is non-numerical data that describes characteristics or attributes. Its examples include categorical data and ordinal data. Next is nominal data. It is a data that has no inherent order or scale. Examples include names, IDs, categories. These all do not inherent order or scale. Next is ordinal data. It is the data that has a natural order or ranking. Some examples are customer satisfaction ratings. In this, we can have some ranking or order like very satisfied, neutral. And next example can be educational levels. In this, we can have rankings like high school, college, graduate. These are all the rankings or order. which comes one after the other. These are ordinal data. Next is interval data. It is a data with equal intervals between consecutive values. Example is temperature. In this example can be Celsius, Fahrenheit. It will have equal intervals between consecutive values. Next is IQ scores. Next is ratio data. It is a data with the true 0 point and equal intervals between consecutive values. Examples are height, weight, this all. Next is time series data. It is a data collected at regular time intervals. The examples include daily sales data, stock price over time, website traffic. This all time series data. They're all collected at regular time intervals. Next is cross-sectional data. It is a data collected at a single point in time. Next is panel data. It is a data collected over time for the same individuals or entities, like customer purchase history, employee performance data, stock prices over time. These are all the data collected over time for the same individuals or entities. Next is big data. It is a large complex data sets that require specialized tools and techniques to process. Its examples include social media data, IoT sensor data. These are all large and complex data sets. Next is unstructured data. It is a data that lacks a predefined format or organization. Example text data like customer feedback, social media posts, images, audio files. These are all the examples of unstructured data. Next is semi-structured data. It is a data that has some level of organization but not a rigid format, like XML files, JSON data, CSV files. These are all the semi-structured data. Understanding the type of data we are working on with is crucial in descriptive analytics, as it determines the appropriate statistical methods, data visualization techniques, and insights that can be derived from the data. Next, let us explain how understanding the nature of data types is crucial for effective analysis and decision making in different fields. So, understanding the nature of data types is crucial for effective analysis and decision making in various fields. Why? Because it enables professionals to choose the right analysis techniques, to avoid incorrect assumptions, to select appropriate data visualization tools, to ensure data quality, to make informed decisions, to communicate results effectively, to integrate data from multiple sources. These are all the reasons. Next is, in various fields, understanding data types is crucial for businesses, healthcare, finance, marketing, social sciences, environmental sciences, education. In business, understanding data types is essential for market research, customer segmentation, and sales forecasting. It helps in identifying trends, optimizing operations, and making informed investment decisions. Next, healthcare. In healthcare, accurate analysis of patient data, medical outcomes, and treatment efficacy relies on understanding data types. Next, in finance, understanding data types is crucial for risk assessment, portfolio optimization, and investment analysis. Next, in marketing, understanding data types is essential for customer profiling, campaign optimization, and ROI analysis. Next, in social sciences, understanding data types is crucial for survey research, policy analysis, and social program evaluation. Next, in environmental science, understanding data types is essential for climate modeling, ecosystem analysis, and conservation efforts. Next was education. In education, understanding data types is crucial for student assessment, curriculum development, and educational research. It helps in identifying areas of improvement, developing targeted interventions, and evaluating program effectiveness. In conclusion, understanding the nature of data types is essential for effective analysis and decision making in various fields. It enables professionals to choose the right analysis techniques, avoid incorrect assumptions, and make informed decisions that drive positive outcomes. Next, let us define and describe the measures of central tendency. Measures of central tendency are statistical measures that describe the middle or average value of a dataset. They provide a summary of the central location of the data, helping to understand the type or average value of the data. There are mainly three main measures of central tendency. First is mean, second is median, third is mode. So first, mean, arithmetic mean. The mean is the most commonly used measure of central tendency. It is calculated by summing up all the values in the dataset and dividing the result by number of values. We are learning it from very lower class. Example, if 2, 4, 6, 8, 10 are there, so mean will be adding all of them and dividing within the number of them, which will be 30 by 5 is 6. Next is median. The median is the middle value in the data set when it is arranged in order, ascending or descending order. If the data set has an odd number of values, the median is the middle value. If the data set has an even number of values, the median is the average of two middle values. So for example is 1 3 5 7 and these are odd number of values, so the 5 will be the median. Next example is 1 3 5 7 9 11. We have even number of values, so the median will be 5 plus 7 by 2 will be, which will be 6. Next, mode. The mode is the value that appears most frequently in the dataset. A dataset can have multiple modes if there are multiple values that appear with the same frequency. Example, if we have the following dataset like 1 2 2 3 3 3 4, mode will be 3 because it has appeared most frequently. So next is see some key characteristics of measures of central tendency. First is sensitivity to outliers. The mean is sensitive to outliers, while the median and mode are more resistant. Next is skewness. The mean is affected by skewness, while the medium and mode are less affected. Next is data type. That mean is suitable for continuous data, while the median and mode can be used for both continuous and categorical data. Now let us see when should we use this measure. When should we use these measures of central tendency? Mean, we should use it when the data is normally distributed and we want to calculate the average value. Next, median, we can use it when the data is skewed or there are outliers and you want a more robust measure of central tendency. Next is mode, we use it when we want to identify the most common value in the dataset or when the data is categorical. In summary, measures of central tendency provide a summary of central location of the data, helping to understand the typical or average value of the data. The choice of measure depends on the type of data, the presence of outliers, and the level of skewness. Next, what are some real world applications of central tendency measures in various industries? Central tendency measures, including mean, median, and mode, have numerous real world applications in various industries. Example, finance. Mean is used for calculating the average return or investment for a portfolio of stocks or bonds. Median, it is used for determining the median salary for a company's employees to set compensation packages. Next is mode. It is used to identify the most common credit score range for a bank's customers to tailor loan offerings. Next is healthcare. Mean is used to calculate the average blood pressure or body mass index for a patient population. Median, it is used for determining the median length of stay for patients in a hospital to optimize the resource allocation. Mode, it is used for identifying the most common diagnosis or treatment for a specific disease to inform clinical decision making. Next is retail. Mean, it is used to calculate the average transaction value or customer purchase frequency to inform marketing strategies. Next is median. It is used to determine the median price of a product category to set competitive pricing. Next is mode. It is used to identify the most popular product or brand to inform inventory management and supply chain decisions. Next is education. In education, mean is used to calculate the average grades or test score for a class or student population. Median is used to determine the median GPA for a university's graduating class to inform admissions decisions. Next is mode. It is used to identify the most common major or field of study to inform curriculum development and resource allocation. Next applications are in manufacturing, marketing, real estate, sports, transportation, environmental science. These are all the fields which use mean median mode in the real world. These examples illustrate how central tendency measures are used in various industries to inform decision making. Next, let us investigate the concept of similarity and dissimilarity measures in data analysis. Similarity and dissimilarity measures are essential concepts in data analysis, particularly in the fields of machine learning, data mining, and information retrieval. These measures help quantify the degree of similarity or dissimilarity between objects, such as data points, vectors, or matrices. Similarity measures. Similarity measures aim to quantify the degree of similarity between two objects. The most common similarity measures are Euclidean distance, cosine similarity, Jaccard similarity, Pearson correlation coefficient, Kullback Leibler divergence. These are all the some similarity measures. Next, dissimilarity measures. Dissimilarity measures aim to quantify the degree of dissimilarity between two objects. The most common dissimilarity measures are Manhattan distance, Minkowski distance, Hamming distance, Mahalanobis distance, Bhattacharya distance. Applications of similarity and dissimilarity measures are clustering. Similarity measures are used to group similar objects together, while dissimilarity measures are used to separate dissimilar objects. Next is classification. Similarity measures are used to assign a new object to a class based on its similarity to existing class members. Next is recommendation systems. Similarity measures are used to recommend items to users based on their past behavior and preferences. Next is anomaly detection. Dissimilarity measures are used to identify outliers or anomalies in a dataset. Next is data visualization. Similarity and dissimilarity measures are used to create visualizations that highlight relationships between objects. Next, let us see challenges and limitations. Scalability. Computing similarity and dissimilarity measures can be computationally expensive for large data sets. High dimensional data. Many similarity and dissimilarity measures are sensitive to the curse of dimensionality, where the number of features is large. Now, let us explore how these measures contribute to pattern recognition and information retrieval in diverse domains. Similarity and dissimilarity measures play a crucial role in pattern recognition and information retrieval across various domains. Uh, let us explore pattern recognition. First is image recognition. In this, similarity measures like Euclidean distance, cosine similarity, and correlation coefficient are used in image recognition to compare feature vectors and identify patterns. Next is speech recognition. Dissimilarity measures like mel frequency, septral coefficients are used to compare audio signals and recognize spoken words. Next is biometric authentication. Similarity measures like Hamming distance and Jaccard similarity are used in biometric authentication to compare biometric data. Example, fingerprints, facial recognition, and verify identities. Next is anomaly detection. Dissimilarity measures like Mahalanobis distance and Kullback Leibler divergence are used to identify outliers and anomalies in data, which is essential in fraud detection, quality control, and predictive maintenance. Next is information retrieval. First is text retrieval. Similarity measures like cosine similarity, Jaccard similarity, and TF-IDF are used in search engines to rank documents based on their relevance to a query. Next is recommendation systems. Similarity measures like collaborative filtering and matrix factorization are used to recommend products or services based on user behavior and preferences. Next is data mining. Next is data mining. Dissimilarity measures like clustering algorithms, example k-means, hierarchical clustering, are used to identify patterns and relationships in large datasets. natural language processing. Similarity measures like word embeddings, example word to VEC, GLOVE, are used to capture semantic relationships between words and phrases. Next is diverse domains. And first is healthcare. Similarity measures are used in medical imaging to compare images and identify patterns, and in personalized medicine to recommend treatments based on patient similarity. Next is finance. Dissimilarity measures are used in risk analysis to identify anomalies in financial data and portfolio optimization to minimize risk and maximize returns. Next is marketing. Similarity measures are used in customer segmentation to identify similar customer groups, and in product recommendation to suggest products based on customer behavior. Next is environment monitoring. Dissimilarity measures are used in climate modeling to identify anomalies in climate patterns, and in species identification to compare genetic sequences. Next, let us see some important points. First is, let us name three common types of data used in descriptive analysis. Some of the common types of data used in descriptive analysis are quantitative data, which is numerical data, qualitative data, which is non-numerical values, and categorical data, which is grouped into categories or classes. Next is, let us define categorical data. Categorical data is a type of data that is grouped into categories or classes, where each category is a distinct and non-numerical value, such as male, female for gender, or red, blue, or green for favorite color. So here, type of data that is grouped into categories or classes. Next is difference between numerical and categorical data. Numerical data is quantitative and can be measured or counted, whereas categorical data is a qualitative and consists of non-numerical values that are grouped into categories or classes. Next, let us list and define four main types of measurement scales. The four main types of measurement scales are nominal, categorizes data into distinct non-numeric categories; ordinal, ranks data in a specific order but with unequal intervals; next is interval, has equal intervals but no true 0 point; and ratio, it has equal intervals and a true 0 point, allowing for meaningful ratios. Next, let us see some examples for measurement scale. For nominal, example can be favorite color like red, blue, green, etc. Ordinal, example can be educational level like high school, college, graduate. Next is interval. Examples can be temperature in Celsius, 20 degrees Celsius, 25 degrees Celsius, 30 degrees Celsius. So these are example. Next is ratio. Example can be height in meters. Next point, why is it important to understand the measurement scale of data in analysis? Understanding the measurement scale of data is important. Why? Because it determines the appropriate statistical methods and analysis that can be applied, ensuring accurate interpretation and meaningful results, and preventing misuse of statistical techniques that can lead to incorrect conclusions. Next is, let us define mean, median, and mode. Mean is the average value of a data set. Median is middle value when the data is arranged in order, and mode is the value that appears most frequently in the data set. Next, when is the median preferred over the mean? The median is preferred over mean when the data is skewed, it contains outliers, or is ordinal and is provided a more representative and robust measure of central tendency that is less affected by extreme values. Next one, how does the mode differ from the mean and median? The mode differs from the mean and median in that it is most frequently occurring value in a dataset, whereas the mean is the average value and median is the middle value, making the mode a measure of frequency rather than central tendency. Next point, let us name some common measures of variation. Some common measures of variation are the range, which is the difference between the largest and smallest values. Next is standard deviation, which is a measure of how spread out the data is from the mean. Next point, what let us explain what standard deviation represents. The standard deviation represents how much individual data points deviate from the mean, with a small standard deviation indicating that data points are close to the mean, and a large standard deviation indicating that data points are spread out. Next point, how does variance relate to standard deviation? Variance is the square of the standard deviation, meaning that standard deviation is the square root of variance, and both measures describe the spread or dispersion of a dataset.